Welcome back, everyone, to the Deep Dive. Today we're going to be taking a look at Einstein, His Life and Universe. This one by Walter Isaacson. And this time I thought it'd be cool to kind of tackle this deep dive with, our listeners in mind who are really interested in first principles thinking.
Yeah. It's like almost like shadowing Elon Musk for a day.
Exactly.
You know?
He's got this biography. He's got to figure out, how did Einstein do it?
Yeah.
Crack the code. Yeah.
How did he revolutionize physics? What are the core, methodologies or ways of thinking that we can extract from this?
Yeah, and I mean, the book starts off, I think a good place to start would be, kind of just going over Einstein's youth.
Okay.
And, he was kind of this rebellious kid, right? Wasn't the best student, but he was really kind of into how the world worked. And there's this anecdote about a compass that really captures his early curiosity.
A compass. I mean, that seems pretty basic.
Oh.
Right? Yeah. But think about it. This young Einstein is looking at this compass, and he's just mesmerized by the fact that this needle is being guided by this invisible force.
Right.
And that really just sparked in him this lifelong fascination with field theories, this idea that these unseen forces govern the universe. It's like the Matrix.
Oh, so he's looking, past the formulas, past the just rote memorization. He wants to understand the why, the principles that kind of hold everything together.
Yeah. That's exactly it.
This is the first principles approach in action. This is what we've been talking about.
Yeah, and this is a theme we see, throughout Einstein's life.
Okay.
He was kind of skeptical of rote learning.
Yeah.
He often would clash with authority figures, people that prioritized memorization over true understanding.
So he sounds a lot like a lot of our listeners, right?
Yeah.
That kind of challenge assumptions, want to push back on things, think differently. Do you think that rebellious streak that he had, was that essential for his later breakthroughs?
I mean, Isaacson definitely argues that this independent spirit was key. And, if you're constantly questioning, pushing back against these accepted truths, you're more likely to stumble on something innovative.
Yeah. I mean, it makes sense, right? You're not going to discover anything new if you just follow the same path that everyone's followed before you.
Right.
So challenge assumptions. Seek out the underlying principles. Is there anything else from Einstein's early years that kind of sticks out to you?
Yeah, well, one thing I think that's interesting is his relationship with Mileva Maric.
Okay.
They were both physics students at the time.
Okay.
And their intellectual partnership amidst, some personal and familial challenges played a role in his development, I think.
It's like having that sparring partner, you know what I mean? Someone you can bounce ideas off of and kind of refine your thinking with.
Totally. They were constantly debating, challenging each other's theories. Imagine just like the conversations, the whiteboard sessions, like that's where the magic happens, right? So that intellectual friction can really spark incredible breakthroughs.
Yeah, but here's the thing. After graduating Einstein, he was having trouble finding an academic position.
Yeah.
He ends up working as a patent clerk.
A patent clerk? What?
I know, right? I mean, talk about a plot twist.
Yeah.
How does that happen?
Yeah, I know. But, as Isaacson kind of points out, the seemingly, mundane job, it was kind of like a crucible for Einstein's genius.
Really? I mean, how so?
Yeah.
Evaluating patents doesn't sound like a hotbed of scientific revolution.
At face value, you wouldn't think so.
No.
But the work demanded a very critical eye.
Yeah.
A knack for taking these ideas apart and identifying those core principles. He was constantly evaluating inventions, right? Separating the truly brilliant from the flawed.
I see. So he's like training his mind to deconstruct these systems. He's got to get down to the essence of it.
Totally.
Totally core principles.
And remember, all this is happening at a time when physics itself was it was at a crossroads, right?
Oh, okay.
Newtonian mechanics was being challenged by all these new discoveries in electromagnetism. The stage was set for a revolution.
Right. So you've got Einstein. He's got this first principles mindset he's been honing for years, analyzing all these patents. And now you've got all these unsolved mysteries in physics kind of swirling around him.
Right.
It's like the perfect storm.
Yeah. And that storm, I think, it really erupts in 1905.
Yeah.
This year, that would forever change how we understand, the cosmos. 1905, Einstein's miracle year.
Oh, yeah.
It's called that for a reason.
Yeah.
4 groundbreaking papers, each one a revolution.
Wow. So it's like he launched like 4 SpaceX rockets in a single year.
Yeah.
Okay, but let's, unpack that a little. Where do we see these first principles in action?
Yeah. So, take the photoelectric effect, for example.
Okay.
So scientists, they had observed this phenomenon, shining light on certain materials could cause them to emit electrons.
Right.
but nobody could really explain why. Like the prevailing wave theory of light just didn't explain it. It just didn't fit.
Right? It's like trying to launch a rocket with a rubber band. The theory just doesn't have the power.
Exactly.
Yeah.
But Einstein, building on Planck's work with quantized energy, approaches the problem from a different angle.
Okay.
He proposes that light isn't just a wave. It also exists in these like discrete packets of energy, what we now call photons.
So not like a continuous stream of energy, but more like a series of tiny projectiles.
Yeah.
Each carrying a very specific amount of energy.
That's exactly it.
Interesting.
And that energy is directly related to the light's frequency.
Okay.
So higher frequency light, even if it's dim, can still have enough energy to knock loose those electrons.
So it's not one giant rubber band. It's like a bunch of tiny springs.
Yeah.
Each one capable of delivering a very concentrated burst of energy.
Exactly.
Oh, it's fascinating.
Yeah, and this completely revolutionized our understanding of light and really laid the foundation for quantum mechanics. It's a testament to the power of, challenging assumptions and looking beyond that accepted model.
Right. And of course, we can't talk about Einstein without talking about his theory of relativity.
Yeah.
Which always kind of seemed a bit mind-bending to me, I've got to be honest.
Well, those thought experiments we talked about?
Right.
This is where they really come into play.
Yeah.
Isaacson describes how Einstein would visualize these complex scenarios, almost like playing a game in his mind.
Right.
Yeah.
He was famous for imagining himself riding on a beam of light.
Yeah.
What do you think he was trying to achieve with those kinds of mental exercises?
I think he was trying to test the limits of our understanding of space and time. By putting himself in these extreme scenarios. He could expose the cracks in the existing, Newtonian framework.
So instead of just accepting the established rules, he's pushing them to their breaking point. Yeah. Trying to see where the logic breaks down.
Yeah.
That's a great way to find the hidden flaws in our assumptions.
Yeah, and what he realized through these thought experiments is that our perception of space and time, it's not absolute.
Okay.
It's relative to the observer's frame of reference.
Okay, things are going to get weird now.
Yeah.
This is where we get into time dilation and length contraction, right?
Exactly. Time slows down for objects in motion relative to a stationary observer. And moving objects appear shorter in the direction of their motion.
So the universe itself is flexible.
Yeah.
Bending to the rules of relativity.
It's wild, right?
Okay, so let's bring it back down to Earth.
Yeah.
How does any of this apply to someone like Elon Musk who's thinking about interplanetary travel?
Well, imagine designing a spacecraft for a mission to Mars.
Okay.
Right? The faster the spacecraft travels, the more pronounced these relativistic effects become.
So time would actually pass differently for the astronauts on board.
Yeah.
Compared to the people back on Earth.
That's exactly it.
That is wild.
Yeah, it sounds like science fiction, but it's a real phenomenon. And you have to factor that in when you're designing and navigating spacecraft, like GPS satellites, for example.
Really?
They have to account for relativistic effects to maintain accuracy.
So these thought experiments, these seemingly abstract mental games, they actually have real-world implications for technologies that we use every day.
Yeah.
That's incredible.
And that's the beauty of first principles thinking. By stripping away all those assumptions and going back to the fundamentals, you can unlock insights that have the power to transform our understanding of the universe.
Totally.
And drive innovation in some really unexpected ways.
Now, we've talked about the photoelectric effect. We've talked about special relativity. Weren't there a couple other groundbreaking papers that Einstein published that year?
Oh, yeah. He also tackled Brownian motion, provided further proof of the existence of atoms.
Okay.
And then there's his most famous equation.
Yitzhak.
Yeah, the one that everybody knows.
Right, even if they don't quite understand it.
Yeah, exactly. That equation actually derived from his theory of special relativity, demonstrates this equivalence of mass and energy.
Oh, okay.
This concept has some really profound implications, from nuclear energy to our understanding of the very fabric of the cosmos.
So he's taken a sledgehammer to this wall between matter and energy.
Yeah.
Revealing this fundamental interconnectedness.
That's a great way to put it. And that brings us to the next chapter in his journey.
Okay.
1905 was just the beginning.
Right.
Einstein then spends the next decade grappling with an even bigger challenge: how to incorporate gravity into his theory of relativity.
So Einstein, he's this, patent clerk turned physics rock star. He's basically rewritten the rules of space and time and light. So where does he go from there?
Well, he turns his attention to gravity, which at the time was still, governed by Newton's laws. And, and those laws worked, well enough for most everyday scenarios, but Einstein knew there were inconsistencies, like the, slight anomaly in Mercury's orbit, for example.
Yeah. I mean, it's not like he was satisfied with just patching up the old model, right? He
Mm.
wanted to, go deeper, find a more elegant solution.
Yeah.
I think it's this drive for unification that really sets him apart.
Yeah, totally. And that's where his, decade-long struggle to develop general relativity comes in.
Oh, yeah.
Imagine just the mental gymnastics involved in trying to, weave gravity into the fabric of space-time.
Right. That's where that famous trampoline analogy comes in.
Yeah, that's a good way to visualize it.
Yeah.
So, imagine you've got a bowling ball on a trampoline.
Yeah.
Creates a curvature in the fabric.
Right.
That's essentially how Einstein envisioned gravity, not as a force acting at a distance, but as a warp in the fabric of space-time itself, caused by mass and energy.
Oh, so massive objects like planets and stars, they actually bend the space-time around them.
Exactly.
And that's what we perceive as gravity.
That's it. Objects, like a marble rolling on the trampoline, they'll follow the curvature created by that bowling ball. They're not being pulled by some mysterious force. They're simply moving along the contours of space-time.
Okay, I'm starting to see how this could connect back to Elon Musk and his plans for space travel. I mean, imagine trying to navigate a spacecraft through the warped space-time around a massive planet like Jupiter.
Oh, yeah. That's exactly where Einstein's theories become these essential tools,
Right.
Understanding the curvature of space-time is crucial for plotting trajectories, calculating fuel requirements, even communicating with spacecraft across vast interstellar distances.
It's like having a roadmap for navigating the cosmic landscape, right? One that takes into account all the bumps and dips created by massive objects.
And it's not just space travel. General relativity has implications for our understanding of, everything from black holes to the evolution of the universe itself.
It's pretty amazing to think that these mind-bending concepts that come from these thought experiments and mathematical equations, they have such profound real-world implications.
It is, and that's, I think, a key takeaway for anyone striving for, real innovation. Don't be afraid to challenge those assumptions. Go back to those first principles. Explore the seemingly impossible, through these thought experiments. That's where the real breakthroughs happen.
Yeah. It's like Einstein is saying, don't just accept the world as it is.
Right.
Imagine it as it could be.
Yeah.
But he didn't stop there, did he?
No, he didn't. Einstein actually spent much of his later years searching for an even grander theory.
Oh, wow.
A unified field theory that could unite all the forces of nature. Gravity, electromagnetism, the weak and strong nuclear forces into one, single elegant framework.
Right. And that's a quest that, it continues to this day,
Yeah,
right?
absolutely.
Physicists are still trying to find that theory of everything.
They are. And it's a testament to Einstein's vision,
Yeah.
his relentless pursuit of a deeper understanding of the universe.
Mm-hmm.
He knew there had to be this, more fundamental level of reality, a set of principles that governed it all.
Right? It's like that drive to, create a self-sustaining city on Mars.
Mm-hmm.
It might seem impossible right now, but with enough ingenuity and persistence,
Yeah.
who knows what we can achieve?
Exactly. And remember, Einstein's journey wasn't without its setbacks. He faced skepticism, dead ends, years of frustration, but he never stopped questioning. He never gave up on that pursuit of knowledge.
That's a powerful lesson for any innovator,
Mm.
I think. Persistence, resilience, that willingness to embrace failure as part of the process,
Yeah,
that's all essential for achieving those groundbreaking results.
it is.
But, beyond the scientific discoveries, there's something about Einstein that I think really resonates with me.
Yeah, his humanity.
Yeah, he wasn't just this brilliant physicist, right?
Yeah.
He was also a vocal advocate for peace,
Yes,
a humanitarian, someone who used his platform to speak out against injustice.
totally. He saw those dangers of unchecked power.
Right.
Nationalism, blind obedience. He understood that scientific progress without moral guidance could have some devastating consequences.
Right. So as we wrap up this deep dive into Einstein's life and work, what are the key takeaways for our listeners?
I think it comes down to this. Cultivate that relentless curiosity, challenge assumptions. Embrace first principles thinking. Harness that power of imagination. And never, ever stop questioning.
And remember, like Einstein, you have the potential to not just solve complex problems, but to inspire generations to come.
Yeah, the universe is a vast and mysterious place, full of possibilities just waiting to be unlocked. Who knows what incredible discoveries lie ahead for those brave enough to follow in Einstein's footsteps?